Hello and greetings to everyone. We are to correct the following exercises for application. Question 1. Write the following numbers in standard form. For A, we have the number 4,600,000. Question 1. A, we have the number 4,600,000. In standard form, it is simply equal to, we are going to fix the decimal point after the first non-zero digit. Fix the decimal point after 4, and this will give us 4.6 times 10 to the power. We are going to count the number of digits after the decimal point. We have 1, 2, 3, 4, 5, 6. Since we are counting to the right, the power is positive. Therefore, 4,600,000 in standard form is 4.6 times 10 to the power 6. For B, we have the number 0.00000500241. In standard form, it will simply be equal to, we are going to fix a decimal point after the first non-zero digit. That means after 5, we fix a decimal point, and this will give us our A as 5.0241, which lies between 1 and 10, times 10 to the power. In this case, we are going to count to the left. We count 1, 2, 3, 4, 5, 6. We end here. The 6 will simply be negative 6 since we are counting to the left. Therefore, 0.000050241 in standard form is simply 5.0241 times 10 to the power negative 6. We go to question C. We have the number 12 billion. Remember, 12 billion, that means 12,000 million. That's what it means. Since 1 billion stands for 1,000 million, we're going to write 12,000. We attach 6 zeros, and this is 12 billion. In standard form, it is simply equal to 1.2 times 10 to the power. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 12 billion in standard form. For question D, we have the number 0.0 with 10 0, 0.000000000058732. In standard form, it is simply equal to, we are going to fix a decimal point after the first non-zero digit, that is between 5 and 8, and our A will be 5.8732 times 10 to the power. We are going to count the number of digits to the left. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Since we are counting to the left, it is negative 11. Therefore, our answer is 5.8732 times 10 to the power negative 11. We move to question 2. For question 2, find the following products, leaving your answer in standard form. For A, we have the product 5 times 10 to the power 12 times 6.5 times 10 to the power negative 9. This will simply be equal to 5 times 6.5 times 10 to the power 12 times 10 to the power negative 9. And this will simply be equal to 5 times 6.5 gives us 32.5. You can see which is greater than 10 times 10 to the power 12 plus negative 9. This will simply be equal to, we need to express 32.5 in standard form. This will give us, you're going to fix a new decimal point immediately after 3, so as to get the value of our small e. Remember, this is how we express numbers in standard form. This will give us 3.25 times 10 to the power, between the new decimal point and the initial decimal point we have just one digit, times 10 to the power 1 times 10 to the power 12 plus negative 9 is equal to 12 minus 9, which is 3, and this will give us 3.25 times 10 to the power 1 plus 3, which is 4. This is the final answer. We move now to question B. Question B, we have 4 times 10 to the power negative 9 times 2.6 times 10 to the power 14. This will simply be equal to 4 times 2.6 times 10 to the power negative 9 times 10 to the power 14, which is simply equal to 4 times 2.6 gives us 10.4 times 10 to the power negative 9 plus 14. Next, we are going to express the number 10.4 in standard form. Since 10.4 is greater than 10. This will simply be equal to the number 10.4 in standard form gives us 1.04 times 10 to the power 1 times 10 to the power negative 9 plus 14 is the same as 14 minus 9, which is 5. This will be equal to 1.04 times 10 to the power, we are going to add the powers 1 plus 5, which is 6. This is the final answer. We move now to question 3. Question 3. Find the following quotients, leaving your answer in standard form. Is 7 times 10 to the power 7 divided by 3.5 times 10 to the power negative 5. 7 times 10 to the power 7 divided by 3.5 times 10 to the power negative 5. We can express this as 7 times 10 to the power 7 all over 3.5 times 10 to the power negative 5. This will simply be equal to 7 divided by 3.5 times 10 raised to the power 7 divided by 10 raised to the power negative 5, which is as 10 to the power 7 minus negative 5. Applying the laws of indices. 7 divided by 3.5 gives us 2 times 10 raised to the power negative becomes plus. 7 plus 5 gives us 12. This is our final answer. You see 2 lies between 1 and 10. The power 12 belongs to the set of integers. We move now to question B. Question B, we have 8.4 times 10 to the power 9 divided by 6 times 10 to the power 5. This will simply be equal to 8.4 divided by 6 times 10 to the power 9 divided by 10 to the power 5. This will simply be equal to 8.4 divided by 6 gives us 1.4 times 10 to the power, applying the laws of indices, this will give us 10 to the power 9 minus 5. And this will simply be equal to 1.4 times 10 raised to the power 9 minus 5 gives us 4. Our final answer will be 1.4 times 10 to the power 4. We move now to question 4, which says by expressing the numbers 0.0036, 756,000, 1,800 and 800 in standard form, evaluate 0.0036 times 756,000 all over 1,800 times 800, and give your answer for question A in standard form, question B 2dp, question C 2sf. First, we are going to start by expressing the numbers in standard form. For the first one, you have 0.0036 in standard form is simply equal to 3.6. We are going to fix a decimal point here. Then we count the number of digits to the left, 1, 2, 3, 4, times 10 to the power negative 4. Since we are counting to the left, we take the next number, 756,000. In standard form, it will simply give us 7.56 times 10 to the power. If we fix a decimal point here, we count 1, 2, 3, 4, 5 times 10 to the power 5. We go to the next number, we have 1,800. In standard form, it is simply 1.8 times 10 to the power 1, 2, 3. For the next number, we have 800. In standard form, it is simply 8 times 10 to the power 2. If we fix a decimal point after 8, we are left with 2 digits. We are to evaluate 0.00036 times 756,000 all over 1,800 times 800. This will simply be equal to, we are going to replace the various numbers with their expressions in standard form. For the number 0.0036 in standard form, it is 3.6 times 10 to the power negative 4 times 756,000 in standard form, it is 7.56 times 10 to the power 5 all over 1,800 in standard form is 1.8 times 10 to the power 3 times 800 in standard form gives us 8 times 10 to the power 2. This will simply be equal to 3.6 times 7.56 times 10 to the power negative 4 times 10 to the power 5. We divide by 1.8 times 8 times 10 to the power 3 times 10 to the power 2. And this will simply be equal to 3.6 times 7.56. It gives us 27.216 times 10 to the power. We are going to add the powers. Negative 4 plus 5 gives us 1. We divide by 1.8 times 8 gives us 14.4 times 10 raised to the power 3 plus 2, which is 5. This will simply be equal to, we are going to express 27.216 in standard form. Since it is greater than 10, this will give us 2.7216 times 10 to the power 1. Since we fix a decimal point here, we'll be having just one digit in between the two decimal points, times 10 to the power 1 all over, we have to express 14.4 in standard form, gives us 1.44 times 10 to the power 1 times 10 to the power 5. This will simply be equal to 2.7216 times 10 to the power, we are going to add their powers, 1 plus 1 gives us 2, all over 1.44 times 10 to the power 1 plus 5 gives us 6. This will be equal to, we are going to divide 2.7216 by 1.44 times, we are going to divide 10 to the power 2 by 10 to the power 6. This is what it means. And this will simply be equal to 2.7216 divided by 1.44 gives us 1.89 times 10 raised to the power, we are going to subtract the powers, 2 minus 6, and this will be equal to 1.89 times 10 raised to the power negative 4. Question A is asking us to give our answer in standard form. That means for A, our answer is simply 1.89 times 10 to the power negative 4 in standard form. For question B, it is asking us to give our answer to two decimal places. For us to give our answer to two decimal places, we need to express the number 1.89 times 10 to the power negative 4 in full. You know, this will simply be equal to, we're going to write 1.89. Then we are going to move the decimal point 4 places to the left. Since the power is negative, we are going to move it 1, 2, 3, 4. Decimal point here. Then we fill in these gaps with zeros. And this will simply be equal to 0.000189. Question B is asking us to give our answer to two decimal places. To two decimal places, 0.000189 will be approximately, we are going to count the two decimal places, 1, 2. You get to round off between two zeros, and this will be approximately 0.00 to 2 dp. We move now to question C, which is asking us to give our answer to 2SF. We have the number 0.000189. Remember, these four zeros are not significant figures. 1 is the first significant figure, 8 is the second significant figure. We have to round off between 8 and 9. 9 is greater than or equal to 5. It is rounded up to 1. We are going to add the 1 to this 8. This will be approximately 0.00019. This will be the answer, to two significant figures. We move now to the next question. Question 5. Evaluate the following, leaving your answer in standard form. For A, we have 2.9 times 10 to the power 6 plus 3.8 times 10 to the power 5. 2.9 times 10 to the power 6 plus 3.8 times 10 to the power 5. First thing, for us to perform this addition, what we are going to do is we are going to express the two numbers in standard form in full. We take 2.9 times 10 to the power 6 is simply equal to 2.9. We are going to move the decimal point 6 places to the right. 1, 2, 3, 4, 5, 6. Then we fill in the gaps with zeros. And this will be equal to 2,900,000. For the second number, we have 3.8 times 10 to the power 5. This will simply be equal to 3.8. Then we take the decimal point 5 places to the right. We take it 1, 2, 3, 4, 5. We fill the gaps with zeros. And this will be equal to 380,000. Next, we have to add the 2,900,000 with the 380,000 with the 4 zeros. 8 will be here and 3 here. Then we add 0 plus 0, 0, 0, 0, 0, 8. 9 plus 3 gives us 12. We are going to write down 2, we carry 1. 2 plus 1 we carry gives us 3. So this will be 3,280,000. Next, we have to express 3,280,000 in standard form. We are going to fix a decimal point after the first non-zero digit. That means after 3, we fix a decimal point. This will give us 3.28 times. We are going to discard all these zeros because they have no use. Times 10 raised to the power. Count the number of digits 1, 2, 3, 4, 5, 6. This will be the answer. Then we conclude. Therefore, 2.9 times 10 to the power 6 plus 3.8 times 10 to the power 5 is simply equal to 3.28 times 10 to the power 6. We underline the answer. I know in such a question, most people will be tempted to add 2.9 and 3.8 and to add the 10 to the power 6 to 10 to the power 5. It is wrong. This is how we approach such a question. For question B, we have 1.75 times 10 to the power 9 minus 1.25 times 10 to the power 9. First thing, we are going to express these two numbers in full. Then we perform the subtraction and we express our answer in standard form. 1.75 times 10 to the power 9 is simply equal to 1.75. Then we take the decimal point 9 places to the right. Since the power is positive, we take it 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we fill the empty spaces with zeros. 1, 2, 3, 4, 5, 6, 7. And this will give us 1,750,000,000. Next, we have to express the number 1.25 times 10 to the power 9 in full. This will simply be equal to, we write 1.25, then we take the decimal point 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we fill the empty spaces with zeros, and this will simply be equal to 1,250,000,000. Next, we have to subtract the two numbers. We have to subtract 1,250,000,000 from 1,750,000,000. Let's perform the subtraction. 1,750,000,000 minus 1,250,000,000. 0 minus 0 remains 0, 0, 0, 0, 0, 0, 0. 5 minus 5 gives us 0. 7 minus 2 gives us 5. And 1 minus 1 gives 0. And this will give us 500 million. Next, we have to express 500 million in standard form. This will simply be equal to 5 times 10 to the power. If you fix a decimal point after the first non-zero digit, it gives us 5. Then we count the number of digits after the decimal point. 1, 2, 3, 4, 5, 6, 7, 8. 5 times 10 to the power 8. So we conclude therefore 1.75 times 10 to the power 9 minus 1.25 times 10 to the power 9 is simply equal to 5 times 10 to the power 8. This is the final answer. We are done with the exercises for application on standard forms. If in case you have any question, feel free to drop your questions at the comment section. Please like the video, share and subscribe to this channel. Thank you very much for watching.